So welcome students. So in this question you're given that f of x is ax cube minus bx minus tan x times signum x. You're given that this is an even function for all x belongs to real numbers minus odd number multiples of pi by 2. And a is given as sin square alpha minus sin alpha plus 4 and b is given as tan square alpha plus 2 by root 3 tan alpha plus 1 by 3. If that is so, how many values of alpha are possible in the interval minus 3 pi by 2 to 2 pi. So how do we analyze this question? So first let us look at the first information. The first information is that this f of x is an even function. So is it possible that this function is an even function? So if it has to be an even function, f of minus x has to be equal to minus f of x. Sorry, f of minus x has to be equal to f of x because f of x is an even function. So f of minus x is equal to, if you put x is equal to minus x, you get a into minus x whole cube minus ax cube minus b into minus x, that is plus bx, minus tan of minus x is minus tan x, signum of minus x is minus signum x. So you get minus tan x as gn of x. You get a minus outside from tan x as well as from signum x. So you get a minus as it is, whatever it is there. And this is f of minus x. This has to be equal to f of x, that is ax cube minus bx minus tan x as gn of x. So this minus tan x as gn of x gets cancelled. So this implies 2ax cube minus 2bx has to be equal to 0 for all x. So if this has to be 0 for all x, that means simply the coefficients has to be equal to 0. So if the coefficients are not equal to 0, will this expression be 0 for all x? No. So if this has to be 0 for all x, then obviously the coefficients has to be equal to 0. That means from the first information, the conclusion that you get is a is equal to b is equal to 0. Now let us use it in the second equation. So now a is given as this, b is given as this. This implies, so sin square alpha minus sin alpha plus 1 by 4 has to be equal to 0. Has to be equal to 0. So this is nothing but sin alpha minus half whole square. Sin square alpha, a square plus b square minus 2ab is this. So this is equal to 0. This implies sin alpha has to be equal to 1 by 2. And similarly, if you take the second equation, tan square alpha plus 2 by root 3 tan alpha plus 1 by 3 is equal to 0. And this implies, what is this? This is nothing but tan alpha plus 1 by root 3 whole square. Tan alpha plus 1 by root 3 whole square is equal to 0. This implies tan alpha is equal to minus 1 by root 3. So now let us try to look at these two values. I want an alpha such that sin alpha is 1 by 2 and tan alpha is minus 1 by root 3. So obviously 1 by 2 and minus 1 by root 3, 1 by 2 and 1 by 3 are related to 30 degrees. So if you draw the quadrant diagram, so I want my sin alpha to be positive and tan alpha to be negative. And both these 1 by 2 and 1 by root 3 are related to 30 degrees. So now what is the quadrant in which alpha lies? Sin should be positive, tan should be negative. Yes, obviously it's in the second quadrant because the signs of sin are plus plus minus minus and that of tan are plus minus plus minus. So sin has to be positive and tan has to be negative. That means your alpha is in second quadrant. And alpha is allied to which angle? 30 degrees. That means, so you have 180 minus 30, that is 150 degrees as your, so this is your required position of the ray. This is a simultaneous equation. So within one rotation, you get only one solution. So in one rotation, you have only one solution to this equation. So this is the only position of the ray which satisfies this equation. Now the question is, how many solutions are there from minus 3 pi by 2 to 2 pi? So minus 3 pi by 2 to 2 pi. Let us count the number of solutions. So minus 3 pi by 2 is going from this to this. So this is minus 3 pi by 2 and it goes and comes back to 0. So between minus 3 pi by 2 and 0, you have one solution. And you're again going from 0 to 2 pi. That is, you're going one more round. So when you move one more round, you're getting one more solution. You're coming to this position twice from minus 3 pi by 2 to 2 pi. That means how many solutions of alpha are possible? 2 solutions of alpha are possible. Thank you.